Hello everyone, welcome to the Learning Royal. Today, we'll be taking a look at an interesting problem from Singapore. The problem reads, find the least positive integer n such that 2 to the 8th plus 2 to the 11th plus 2 to the n is a perfect square. There are some restrictions though. No calculators were allowed and only about 5 minutes were given to solve this problem. Can you solve this problem? Give it a try. Okay, let's see how we can solve this problem. Because our expression is equal to a perfect square, we can set our expression is equal to some number squared. Because the perfect square is some number squared. Now, let's see, we have this expression. Because we're trying to find the value of n, let's separate 2 to the n from on one side of the equation and the rest of the terms on the other side of the equation. So that becomes 2 to the n equals m squared minus 2 to the 8th minus 2 to the 11th. Now let's see, how can we simplify this side a bit more further? Well, we can always, we have 2 to the minus 2 to the 8th minus 2 to the 11th. We can simplify this into minus 2 to the 8th times 1 plus 2 to the 3rd in parentheses. Because minus 2 to the 8th times 2 to the 3rd is basically minus 2 to the 11th. Now let's try to plug in what 2 to the 3rd is, which is going to be 8. And we have 1 plus 8, which is going to be 9. Now we have this term. Can we simplify this any further? Well, our first number is a perfect square, we know that. If our second number is a perfect square, we can apply the distance of a squares formula. So, let's see. Is the second number a perfect square? Well, 9 is a perfect square, and 2 to the 8th is also a perfect square of these respective numbers, which are 3 and 2 to the 4th. So this number must be a perfect square. Well, what perfect square is it? So for that, first let's find out what 2 to the 4th is, which we'll plug in as 16. And then 16 squared times 3 squared is 16 times 3 whole thing squared, which is 48 squared. So we have 2 to the n equals m squared minus 48 squared. Now we can basically just use the difference of squares formula, which is x squared minus y squared is equal to x plus y times x minus y. Using that formula, we get 2 to the n is equal to m minus 48 times m plus 48. Now, let's think of some other, let's think of a factor of this 2 to the n. It can just be m minus 48 or m plus 48. Let's just think of n plus 48. Let's say 2 to the k is equal to m plus 48. Because both of them are factors of 2 to the n, they must also be factors of any 2 to the x power integer. So let's just say 2 to the k is equal to m plus 48. Then 2 to the n over 2 to the k, which is 2 to the n is this m minus 48 times m plus 48 over m plus 48. This whole thing. And that's 2 to the n over 2 to the k. Well, let's simplify this further into 2 to the n minus k equals m minus 48. Now if we subtract these two quantities, we'll get rid of m. So let's get rid of m. So 2 to the k minus 2 to the n minus k is equal to m plus 48 minus m plus 48 this time, because this negative 48 is negative, which becomes 48. So let's simplify both sides. This side will only be 48 plus 48, which will be 96. And this side, let's see, how can we simplify it? Well, if we have 2k, if we simplify n minus k out of both of them, then this one will just be a negative 1. And this one will be 2k minus n. So we can do that. So 2 to the n minus k times 2k minus n power minus 1 is equal to 96. Well, we know that these two are factors of 96 and that they're positive whole numbers, and we also know that this factor is any power of 2, and this factor is an odd number, which is any power of 2 minus 1. So let's see a factor of 96 like that. Well, 96, its power of 2 is 2 to the 5th in prime factorization. So let's just think of this equation as 2 to the n minus k times 2 to the 2k minus n minus 1 is equal to 2 to the 5th times 3. Well, then the 2 to the 5th is the 2 to the n minus k factor, and 2 to the 2k minus n minus 1 is the 3 factor. Well, we can simplify this further because we know these 2 to the n minus k is equal to 2 to the 5th and n minus k is equal to 5. We have one equation. Well, we can use the second factor to the 2k minus n minus 1 is equal to 3. That will be 2 to the 2k minus n is equal to 4. To the 2k minus n equals 2 squared, and 2k minus n is equal to 2. Now we basically have a system of equations which we can solve by elimination, and we'll get k equals 7 and n is equal to 12. So our answer is 12. That's it for this video, guys. Please make sure to like the video if you liked it, and to stay updated, please subscribe and click the bell icon. Thank you.